D, we're going to be trying out problems that's connected by OR. So take a minute to complete these problems before you continue with the video. Once you have completed parts C and D, we can look at part C first. And to decide the scale over here, depending on how much room you have, again, you can go by any consistent scale you have. And here with my space, I think I'm going to scale the y-axis by 2 over here, meaning every time I go up, it'll be going up by 2 over here. And similarly on the negative side, we have -4, because I need to go all the way to -13. Makes that easier over here. And in this case, we also have all the other restriction to be relatively small numbers, so that's fairly easy to scale the x-axis to be going up by 1 every time over here. So now going back to the initial problem, we can again designate y1 to be -2x minus 3 and y2 to be 1/2 x minus 1. Over here we can see the slope is -2 for the first line, so we can say this is really -2 over 1, and the y-intercept is 0, -3. And similarly for the second line, we get the slope is 1 over 2, and the slope, the y-intercept being 0, -1 over here. So going back to the graph, if I have 0, -3 to start with, that will be right over here. And if I want to make the slope equal to -2 over 1, that means every time I go down by 2, I should go over to the right by 1 over here. And with my scale, it's fairly easy to go down by 2 every time. And you could keep going until you have enough points to give you a good idea as to what the line looks like. And here I have 5 points, and I'm going to go ahead and connect points over here. And we get y1 is over here. And then we have the restriction being -13 exclusive. So -13 is going to be the halfway point between -12 and -14. So somewhere here, I think we can do this. So that's where -13 is, and we can see an intersection already right over here. And as I said, we are expecting integer solutions when we're graphing by hand over here, so that makes it a bit easier to see the intersection more exactly. And we get the x-coordinate would be 5, and the y-coordinate was -13 over here. And here we are looking at the part that's less than -13. So we want the part that's below -13, meaning this part of the line. And if I want to write it out as in an inequality for the solution, we get x is going to be strictly greater than 5, because it's to the right of the x value being 5. Now on the other line, 1/2 x minus 1, we see the starting point for the y-intercept. It's 0, -1, so that's right in the middle over here. And the slope being 1 over 2, so every time I go up by 1, I should go over to the right by 2. So go up by 1, go over by 2, looks like this. And you can also go up by 2 and go over by 4. If you want. That makes your points a little bit easier and more exact because it's right on the dot. So if we go by 2 every time, you can think about the slope is really equal to 2 over 4. So go up by 2 and go over by 4 gives me this point. And as we have enough points, we can again go ahead and connect the points. and that will be what my y2 looks like. Here y2 is being bounded by 3 from the above. So it would look like this. And 3 is included as part of the boundary, so 3 can be included. And now if I look for the intersection, it's right over here, and we get 8, 3 being the coordinates for the intersection. And here, if I want x or the line to be greater than or equal to 3, that means I'm looking for this part of the line. And if I want to write out the symbolic way to represent it, x has to be greater than or equal to 8, because I'm looking at the x coordinate. And with this restriction, because we have the restriction included by or, we would have the case that any part of the number line that's covered at least once will be part of the solution, and that cutoff point happened right over here, right at 5. And anything from 5 and beyond, they're covered at least by one highlighted area. So we can say the solution is going to be x such that x is greater than 5, because 5 is not included. This is a set notation, or you can say 5 to infinity for interval notation, and that's how we solve it. Now that you have seen this one, again for the last problem, it's going to be very similar to what we have done before with inequalities connected by or. I have a little bit more room, so I kind of made my coordinate plane fairly large over here, and that gives me more flexibility in terms of working with fractions. And here I think I have enough room for fitting all the numbers by going with a scale being 1 on both x and y axes over here. So here we have 0, and I'm just going to label every other unit. And similarly for the y direction, we would have 4, 8, 12, and on the negative side, -4, -8, -12, and just enough for -16. Alright, so now going back to my equation, I had 3x minus 1/2 is greater than or equal to 11 over 2. So I can let my y1 equal to 3x minus 1/2 and y2 equals 4x plus 12. With the slope being integers over here. So it's 3 over 1, and the y-intercept is 0, -1/2. Then for the second line, the slope is 4 over 1, with the y-intercept being 0, 12. So let's start from the first inequality. We have 0, -1/2. So -1/2 will be right over here. And I'm going up by 3 while I go over to the right by 1 every time. So going up by 3, 1, 2, 3, and go over by 1 will be over here. Up by 3, over by 1. And we can go ahead and connect the points to get the line. And here I want it to be greater than or equal to 11 over 2. You can kind of convert it to decimal or a mixed number. We'll get 5.5 as a result. So 5.5 should be right over here. We can see this is where exactly our point goes through over here. And it's inclusive, so we use a solid line for y equals 11 over 2. To find the intersection, we can see the x-coordinate was 2 and the y-coordinate is 5.5, as we found out. And if we want the y value to be greater than or equal to 11 over 2, we're looking at this part of the line, meaning x needs to be bounded below, or x is greater than or equal to 2 as a result. And similarly for the y2, if we want to graph it, we would have the starting point at 0, 12. It's quite a high starting point. So if we want to have a boundary, it makes sense that we want to go downward. There's not much room to go upward to draw the line. And if we know the slope is 4 over 1, that means every time I go down 4, I need to go to the left by 1 over here. And again, go down by 4, go over by 1 to the left. And that's going to be our points on the line. So we would get this being y2. And similarly, because it's bounded by negative 16, actually I might want to draw the line to be a little longer over here, just so we can see where it intersects with negative 16. So I'm gonna go all the way down. And this is going to be helpful to kind of see where the intersection happens exactly. Okay, I think that's long enough. And we would get y2 over here. And we would get the restriction related to negative 16. And it's not including negative 16, so we would use a dotted line. So I have y equals negative 16 over here. And to find the intersection, we can see it's right over here. And if we want to find the exact intersection, we would get this point. If we line it up, it's right over here, which would be negative 7, comma negative 17, negative 16. And here, if we want it to be below negative 16, we can see it's anywhere to the left of this point. And therefore, we would get x is less than negative 7 over here. And as a result, if we want to find the final solution with the inequalities connected by or, we just want to include all the solution that's included or covered at least by one highlighted part. So we can say the solution is in set notation. X is either going to be less than negative 7 or x is going to be greater than or equal to 2 over here. In other words, we can also write the interval notation. Because we have two separate intervals, we are going to connect them by union. For the first interval, it starts from negative infinity, going all the way to negative 7, excluding negative 7. And union, remember that means we are connecting two intervals. And here we're starting at 2 and going all the way to infinity as a result. And that's going to be the solution for the last problem over here.